Good morning, students. My name is Dr. Mahadevaswamy. Today, I'm going to discuss about biopolymers. So here, the biopolymers. Why we want biopolymers? Why we are expecting to take the biopolymers nowadays? Because so many strategies we have. So we are discussing one by one. So first one, we taking the plastic waste and the pollution have come to have a forefront of public attention in recent years. But it's only when you see the statistics that you realize that sheer scale and complexity of the problem. We have researched and gathered the latest key plastic industry data in five main areas: plastic waste generation, plastic production, recycling, pollution, and the future outlook. You learn how much plastic is already out there, how much more is being produced each year, and what is used for. Also, how much gets recycled, how much goes to waste, and what happens to it. So, one by one, we are going to discuss how much waste we are generating and country wise we are going to take in the statistical manner. Yeah, just you see this, these are the key factors. The world produced around 400 million metric tons of plastic waste every year. 10 million tons of plastic per year end up in the ocean. China is the world's largest plastic producing country with a 32% share of global production. US, around 42 metric ton, produces more annual plastic waste than any other country. 50 billion plastic water bottles are sold each year in the US. On an average, just 18% of plastic is collected for recycling. Just to think, just to wait 18%. So we are producing a lot, but we are collecting for the recycling only 18%. Just you think about that. In India, 60% is the country with the best plastic recycling rate. There are currently 5.25 trillion pieces of plastic in the oceans. So under the ocean, we are getting a 5.25 trillion pieces. Just imagine that. So we are calculating this, the plastic waste generation statistics. So it's really we are getting where we are still. So how we are going to overcome this, and then how we are going to stop this type of plastic production. So because of this, just you see this, the plastic waste generation statistics here, United States 42, then 130 upper scale, then lower scale is the 42. This is the waste generation country, highest waste generation country. Then India 26.3 and 19.9. So another one is, this is the total plastic waste metric tons. Okay. Then China 21.6 and 15.7. This is the lower scale and then higher scale range. We plotted the graph here. Then Brazil 10.7 and 51.8. So another one is Indonesia 9.1, another 34.9. So what we are getting this, so United States is the more, another what we are generally called is the worst 5 countries. So first one is the United States. So next, when we are taking this, what exactly does plastic waste comprise? What we are getting this? How we are going to overcome this type of problems? So first, what we are thinking, so this is the worst case. So in another 10 to 15 years, we are going to do like this only. So what we are getting, we are completely it will pollute the pollution. Then what happen? It will biodegradable. It's really impossible. Then what we are getting, wherever we want, wherever you go, so that is filled with the plastics. So that's why we are going to reduce this type of plastic material. So here, just you see this here, staggering 46 of plastic waste comes from packaging. Then this comprises everyday items including containers such as bottles, pots, tubs and trays, and wrapping such as plastic shopping bags, then rubbish bags, bubble wrap and shrink wrap. So these are the some important waste materials every day what we are using. That is. These are the areas in which our choices as individual can have a massive effect. By choosing eco-friendly plastic alternatives, we can all help to reduce this creeping amount of waste. So how we are going to reduce this type of plastic? So what is the alternative plastic? Alternative for this type of plastic? So the only thing is we are using that is nothing but biopolymers. What is that biopolymer? Just you see this. These are all the things we are using. We are adopting all the things, but it's difficult to come out from this type of materials what we are using day to day life. So we are taking the alternatives. So whatever the usage we are taking from the plastic, we are replacing that plastic. In place of that, biopolymer or degradable polymer we are going to replace. So just you see this here. What are biopolymers? So the biopolymers are a long chain compounds made up of a long chain molecule subunit. So bio is nothing but what? It is nothing but we are getting from the nature and then it is decomposed easily. So that is nothing but bio. Bio means eco-friendly and then nature friendly. So that's why we are taking that in place of that plastic. So example, starch, cellulose. So these are all the bio-friendly plastic monomer units. Okay. Then what we are going to take? The monomer collecting, then joining together, we are getting the plastic like the chain like structure that is nothing but a starch and then cellulose. So next, these are biodegradable, eco-friendly and are obtained from natural sources. Already discussed about this natural source. It is nothing but biodegradable one. Next, here bio-based and biodegradable. What is this bio-based and biodegradable? First, we are taking that bio-based, a renewable product engineered or composed in whole or in a significant part from plant or animal material. So we are generally called this one as a bio-based material. Then biodegradable is nothing but what? Material that left to itself will be decomposed by natural process. For example, microorganisms, it will converting into biodegradable. So that's why what happened, the plastic, it will take nearly 20 years, but when we are taking biodegradable, it is immediately it will decompose. So that's why we are using alternative for the plastic. One is bio-based material, another one is biodegradable one. Then next one, origin of description of bio-based polymers. So what are those? Bio-based polymers may be divided into three main categories based on their origin of the production and the production. Category 1, polymers directly extracted or removed from biomass. Example are polysaccharides such as starch and cellulose and proteins like casein and gluten. So these are the category 1 type of bio-based polymers. Category 2, polymers produced by classical chemical synthesis using a renewable bio-based monomer. A good example is the polylactic acid, then esters polymerized from lactic acid monomers. The monomers themselves may be produced via fermentation of carbohydrates or feedstock. So this is the second category of the bio-based polymers. Then third category, polymers produced by microorganisms are here genetically modified bacteria. What we are going to take? Genetically modified bacteria. So to date, this group of bio-based polymers consists mainly of the polyhydroalkane, hydroxyalkanates. But developments with the bacterial cellulose are in progress. So these are some three category of the bio-based polymers. So just you see this. These are the bio-based polymers example. So one is we are getting it directly from that. What we are discussing the previous one, category 1 polymers. The category 1 polymers is nothing but directly extracted. Just you see, this is the directly extracted one. Okay. So the second one is a polymer produced by classical chemical synthesis. Just you see this classical chemical one. So classical chemical is nothing but we are making with the you see what is the synthetic material one. The byproduct we are going to use. Okay. So classical chemical synthesis using a renewable bio-based monomer. Then third category, polymer produced by microorganism or a genetically modified one. Just you see this here. Yeah, genetically what we are taking, that genetically what with this colored compound, no, so that is the genetically modified one. Another one is corns, no, corn, the cover of the corns is nothing but what, it is a hybrid one. So genetically modified one, that is a modified, then high yield crop, then we are taking that one as a biopolymers, biodegradable polymers. The next one here, composition of bioplastics. Here just you see this plastics can be made from any different sources and materials. So what are those materials? It's very simple. We know that is what we already discussed. It is a material getting from the nature or a source, natural source, that is nothing but a plantile, cellulose, corn starch, then potato starch, sugarcane, hemp, etc. So these are all the material we are collecting from the plant. So that's why we are what we are going to call a composition of the bioplastic. So next, composition. Just you see this. These are the images I introduced here. This is nothing but a plant oil. Then starch, we are getting a powder like material. Then cellulose, it is nothing but a viscous, very viscous material. Then potato, we know that already. Then corn, then sugarcane. So these are all materials we are collecting all the things. Then we are preparing the material like a plastic. So here, the classification of bioplastic. Starch-based plastic. So starch-based plastic is nothing but a bioplastic produced from classical chemical synthesis from bio-based monomers. The second one is polyacetic acid, PLA. We generally call this one as a PLA plastic. So it is nothing but bioplastic produced directly by natural or genetically modified organisms. Then another one is polyamides. So polyamides is nothing but what we are going to call caprolactam, polycaprolactam. So this is also another one biopolymer class of the biopolymer. See, these are all what L-lactic acid, then D-lactic acid. These are the monomer in it. So we are taking this L-lactic acid and D-lactic acid, then we are converting that one as a polymer. So how we are going to convert that one as, just you see this direct condensation process and then polymerization through lactide formation. So in this formation, lactide formation, another one is direct condensation process. The direct condensation process, we are getting a polymer. So that polymer name, what we are going to call low molecular weight polymer. Low molecular weight polymer. So the low molecular weight polymers around 10,000 to 5,000 daltons is the molecular mass. Then second one, what we are taking that polymerization through lactide formation. So this is the low molecular weight. So what we are going to call, this is also low molecular weight. The pre-polymer process here, this is also around 1,000 to 5,000 molecular mass is there, the daltons. Okay, the unit is daltons. So then this converting into lactide. So this is the ring type or cyclic formation polymer process taking place. Okay, polymer product formation. Then the center one, what we are taking that azeotropic dehydration condensation. So we are replacing of the water molecule from that monomer. Then we are converting the high molecular polymers we are getting. So that high molecular is nothing but greater than 1 lakh daltons. So 1 lakh molecular mass is there at that what we are generally called high molecular weight polymer. So these three different products we are getting from this L-lactic acid, another one is dextro and lactic acid monomer we are getting these type of product we are getting, okay, at the end. So these high molecular weight polymers and then low molecular weight polymers, we have lot of applications. Here just you see this with the help of this polylactic acid, with the help of the polylactic acid. Polylactic acid is nothing but what we already discussed that polylactic, where we are getting the lactic acid, we are combined together, then finally we are getting a low molecular weight, another one is high molecular weight polymer we are getting. With the help of this, we are make these type of different types of plastic type materials. Okay, so decorative materials, then cup type materials, and then flowers type of material. But 100% these are all not plastic. It is what is that? It is what we are using. It is a plant source itself. Plant source. We are not using plastic materials. Then advantages of bioplastics. So we know already, because we facing so many problems, so many difficulties from the plastic. So it's difficult to survive after 15 years with the help of what we are using every day, that plastic bags, then plastic covers, then so many things. So that's why so many advantages are there in this bioplastic. The need of replacement of the petroleum based plastic with the bioplastic is just because of producing a conventional plastic. We already know that is because we know the calorific value of that in the last slide. So similarly, we are completely replacing that one alternative for the what is that conventional plastic. The producing conventional plastic consumes 65% more energy than producing a bioplastic. The conventional plastic are mostly toxic. Yeah, we know already. Okay, it is why, because it will take more time to take for the degradation, but it will less time for the degradation process. Then plastic lasts a long time and do huge damage to environment. Therefore, plastic is absolutely unsustainable, and bioplastic is more sustainable nowadays. Then bioplastic saves 30 to 80% of the greenhouse gas emission and provide a longer shelf life than normal plastic. Thank you very much.